This video covers 2.7 problem-solving geometry and uniform motion, Objective 4, set up and solve uniform motion problems. Before we get started with Objective 4, I'd like to remind you of the formula involved with uniform motion problems. Uniform motion, so this deals with movement, miles per hour, distance, and rate. So when we see something that has a miles per hour in it, a miles, or maybe something in hours, we know to use the formula that the distance is always equal to the rate times time. The time it takes to travel 300 miles, that is a distance, 300 miles. Going 40 miles per hour, that is a rate. The miles per hour is what leads us to know that that is a rate. So we plug those into the formula: distance equals rate times time. Distance equals 300. Rate is equal to 40, and that leaves the time unknown. We want to find the time. So we take the distance of 300 and divide by the rate of 40. And we get 15 halves, or 7.5 hours. So the time it takes to travel 300 miles going 40 miles per hour will be 7.5 hours. So this will be the formula that we always write down anytime we see a uniform motion problem. Uniform motion formula: if an object moves at an average speed, r, that's your rate, the distance d covered in time t is given by the formula distance equals rate times time. In all these problems, we will write the formula down at the top as rate times time is distance. We will have two different pieces of the trip. It could be object 1, object 2, or it could be out to a resort, back over the same road. And every time we do this, we're going to fill in their rates, their times, and use the formula to fill in for their distances. The table always helps us set these problems up. I strongly urge you to use a table. So I'm going to take this table and we're going to place it in each one of our uniform motion problems. So in example 5, it says two bikers, Jose and Luis. So those are our two different objects. They start at the same point at the same time and travel in opposite directions. Jose's average speed is 5 miles per hour, more than that of Luis. And after 3 hours, the two bikers are 63 miles apart. Find the average speed of each biker. So we'll place down their information in this table. First, the two people that are biking are Jose and Luis. Their rates. We're looking for miles per hour. Jose's speed or rate is 5 more than that of Luis. So if Luis's rate is L, Jose's is 5 more than Luis's. Times the time they travel, and they're both going to travel for 3 hours. And then that gives us the distance that they've traveled. Jose's traveled 3 times 5 plus L. Luis has traveled 3 times L. And if you look back up in the problem, there's one number that we haven't used yet. The fact that the two bikers are 63 miles apart after 3 hours. So you have to ask yourself, how are these two distances related to each other? Jose's distance is 3 times 5 plus L. Luis's is 3L. I like to draw a picture to see this. They both started from the same point and traveled in opposite directions. Jose traveled a little faster than Luis. So after 3 hours, he will have gotten a little bit further than Luis. But when we look at this together, Jose's distance and Luis's distance together, those two distances must add up to 63. So the sum plus of their distances is 63. So we add them up. 3L plus 3 times 5 plus L equals 63. And there's our equation to solve for the speed of Luis. We distribute the 3 across, gives us 15 plus 3L. The left side, we have 3L plus 3L, which is 6L. And now we solve this standard equation, AX plus B equals C. We subtract 15 from both sides. And we have 6L is 48. And dividing by 6 gives us L equals 8. Luis's speed, (8 miles an hour), and Jose, well, his speed then is going to be 5 plus L, or 13 miles an hour. 8 miles an hour and 13 miles an hour. Now we should make sure they got 63 miles apart, though. They travel for 3 hours, so 3 times 8 is 24. 3 times 39. 3 times 13 is 39. 9 plus 4 is 13. 2, 3 plus 3 is 63 miles apart. Okay, so again, we start with the table. We're going to fill in the 4 boxes. 1, 2, 3, 4. And use the formula to come up with the distance. Tanya, a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves the house, you leave in your car and follow the same route. If your average speed is 40 miles per hour, how long will it take before you catch up to Tanya? How far will each of you be from your home? This time it's a different scenario where we're both going to leave from the home. Tanya leaves, starts running, and for 2 hours she runs while we sit in the house. We then start to take off after her to try to catch her. She's going 8 miles an hour. We're going to go 40 miles per hour, so we have to go faster than her to catch her. But as we go, she's still running, but she runs so slow compared to us that pretty soon we're going to end up catching up with her. So this is a catch-up game. The key words in this problem are catch up to Tanya. More on that in a little bit. So Tanya runs at an average speed of 8 miles per hour. Rates are miles per hour. 2 hours after Tanya leaves the house, you leave in your car and follow the same route to catch her. You average 40 miles per hour. Now, the times are a little bit harder this time because we want to know how long it will take us to catch up to Tanya. So we want to know how long we travel for, or you. We want to know how long you travel for. And so we're going to spend less time driving than Tanya does because Tanya leaves 2 hours before us. She's been traveling for 2 whole hours while we sat at home and did whatever we wanted to do, and then took off and started trying to catch her. So that means she travels for 2 more hours than we do. So there they are. 4 boxes filled in. Distance is rate times time, 8 multiplied by t plus 2, and 40 times t. Now you ask yourself what to do with these 2 distances. And we look at the picture, and Tanya's distance and your distance, they are exactly the same. So we set these 2 distances equal to each other. All right, so we solve that by distributing the 8 across. 8 times t plus 8 times 2 is 16 equals 40t. And we'll subtract 8t from both sides. Subtract that. 40 minus 8 is 32t. We divide both sides by the coefficient of t, which is 32, and we get t equals 16 over 32, which is 1/2. So it takes us 1/2 hour to catch up to Tanya. Tanya will have traveled for 2 more hours, so she travels for 2.5 hours, or she runs for 2.5 hours. But we were asked just for the half hour. But now we want to know how far will each of us be from your home. And here's one way to check that this is correct. Tanya runs for 8 miles an hour times 2.5 hours, and we run for 1/2 hour at 40 miles an hour. Rate times time is going to be the distance away. 40 miles an hour times 1/2 hour is 20 hours. 2.5 times 8, 2 times 8 is 16, and 1/2 of 8 is 4, so 16 plus 4 is 20. So we're 20 miles from home. So quite the runner that Tanya is there, 20 miles. Okay, so this leads you to a practice problem for you. I urge you to press pause on the video and try this problem. Remember to draw your table, fill in 1, 2, 3, 4 boxes, use the formula to multiply across to get the distances, and see how those distances are related to each other. Be careful with this problem. There's a trick in this. The rates are set at 45 miles per hour, 54 miles per hour. The trick is if the trip home took 20 minutes less than the trip to the resort, the minutes is a mismatch of the hours versus minutes. So instead of using 20 minutes, use 1/3 of an hour less than the trip to the resort. Don't use the 20 minutes. Use the fact that it's 20 minutes is 1/3 of an hour. If the trip home took 1/3 hour less than the trip to the resort, how far is the resort from the family's home? Okay, please press pause on your video, try this problem, and come back when you're ready to see it worked out. All right, now that you've had a chance to work this out, we have a family that drove to the resort and later returned home on the same road. So they went the same distance to the resort and home. To the resort, they drove 45 miles an hour. From the resort to home, they went 54 miles an hour. It doesn't matter which one gets the T here for the time, but what we need to recognize is that when you go faster, you spend less time driving. So if we go to the resort at T for T hours, home is going to be 1/3 hour less than that. Our boxes are filled in, so now we multiply 45 by T for the distance to the resort, 54 times T minus 1/3 for the distance home. Now we see that they drove the same distance to as home. So we have the same distance, 45T is the same distance as 54 times T minus 1/3. We solve that by distributing the 54 across. 54T minus 18. And we subtract 54T from both sides. (45 minus 54 is -9. And so we divide by -9 on both sides. T equals 2. So it took us 2 hours to the resort, 1/3 hour from less than the 2 hours. So that's T minus 1/3 is 2 minus 1/3, which is 5/3 or 1 2/3 hours from the resort. And so the distances are 45 times T, which is 45 times 2, 90 miles, or 54 times T minus 1/3, which is 54 times 1 2/3, which is 5/3. All right, so it's checked out that it's 90 miles from the family's home. All right, this concludes the video for 2.7, Problem Solving, Geometry and Uniform Motion. Objective 4, set up and solve uniform motion problems.